Imagine if you asked ChatGPT a multi-step question and triangle ABC. If side AB is 10 and the cosine of angle B is 45, what are the lengths of the other sides? For such mathematical reasoning problems, AI often needs to track a large amount of historical information to arrive at an answer, and sometimes it gets lost in the reasoning process. Why do powerful language models like GPT still struggle with basic reasoning? Today, we're going to share a paper from a research team at the Hong Kong University of Science and Technology who proposed an innovative solution, enhancing AI's reasoning ability through atomic thinking. This research team proposed a framework called AOT, Atom of Thoughts, aiming to fundamentally address the shortcomings of large language models, LLMs, in complex reasoning tasks. Let's take a look together at how researchers enabled AI to learn to build reasoning abilities from the most basic logical units, just like humans. In the past few years, we have witnessed the rapid development of large language models. They are like thinking brains, capable of writing code, composing poetry, and even engaging in natural conversations with humans. However, when we closely observe the performance of these models, we find that they still get confused on tasks that require rigorous reasoning. For example, when we ask the model some simple logic questions, they usually perform well. But when the problem becomes a bit more complicated, like the triangle problem we just mentioned, the situation is completely different. Let's take a look at why this seemingly simple geometry problem can stump AI. Traditional language models, when solving this problem, are like a student with an excellent memory but a somewhat rigid way of thinking. It would think like this. Okay, I need to remember that AB is 10, actually minus 4 fifths. Oh, and I also need to use the cosine theorem. The formula is b squared equals a squared plus c squared minus 2ac times cosine b. Wait, I also need to calculate sine b using cosine squared b plus sine squared b equals 1. You see, the model needs to remember and process too much information simultaneously during problem solving, giving conditions, formulas, intermediate results, reasoning steps. This information accumulates like a snowball. This not only consumes a lot of computational resources, but also makes it easier for the model to lose direction during reasoning, just like how our thoughts become more tangled when solving problems. How did the research team solve this problem? Their inspiration came from a small habit humans have when solving problems. We write down important intermediate results on scratch paper and then use this result directly later without rederiving it every time. Based on this idea, they designed the AOT framework, which stands for Atom of Thoughts, and it includes two key steps. The first step is decomposition. Just like dismantling building blocks, the system will break down complex problems into several independent small problems. For example, our triangle problem requires a series of ordered steps. First, calculate the value of sin b using cosine Sewers plus sine Sewers of b equals 1. With this foundation, we can use the sine theorem to find an unknown side length, and finally, use the cosine theorem to calculate the last side length. The relationships between these small problems will form a directed acyclic graph, DAG, like a clear roadmap for solving the problem. This ensures a structured and logical approach to problem solving. The second step is contraction. This step is particularly ingenious, somewhat like drawing a box around important results when solving problems. For example, after calculating sin b equals 3,5, the model treats this result as a new known condition, completely without needing to remember how it was calculated. In this way, each step of reasoning becomes simple and clear without being disturbed by historical information. The experimental results also prove the effectiveness of this method. On datasets like Hotpot QA that require multi-step reasoning, when the AOT framework is applied to GPT-4o Mini, the accuracy F1 score reached 80.6%, which is 3.4% higher than reasoning models such as O3 Mini and 10.6% higher than DeepSeek R1. This improvement is quite significant. What is even more surprising is that this framework also brings several practical benefits. Firstly, since there is no need to remember so much historical information, computational efficiency has been significantly improved. Secondly, the entire reasoning process has become exceptionally transparent. We can clearly see how the AI thinks step by step and arrives at an answer. Most importantly, this framework also has strong versatility. It can be flexibly combined with other reasoning methods, just like a plug-and-play enhancement module. This study gives us an important insight. Sometimes the key to solving problems is not to pile on more computing power, but to find smarter ways of thinking. Just like building a house, instead of rushing for speed, it's better to lay a solid foundation first. Looking ahead, this atomic thinking-based approach is likely to become a new direction for AI development. We look forward to seeing more researchers continue to explore this path, making AI's reasoning abilities more closely resemble those of humans. All right, that's all for today's sharing. If you're interested in this topic, feel free to leave a comment and discuss in the comments section. Remember to like and subscribe, and we'll see you in the next episode.